Good morning to all. Myself, Sreekanth. I'm working as assistant professor in Department of Computer Science and Engineering, Data Science. So today I want to discuss about functions concept in Python. So we'll discuss what exactly functions. Okay. And the agenda of today's session is why functions, what is a function, what exactly function definition, what is function call, types of functions, arguments passing, different ways to pass arguments to the function, and different types of functions like lambda functions and mapper, reduce, filter functions, and finally we need to discuss about the recursive function. So we'll discuss one by one concept, why we require functions, first concept, then after that one by one, and why we require the functions. Functions are main basic building blocks for any Python programming language or any language, not only Python, any programming language. Functions are basic building blocks. So the main purpose of functions or advantage of function is, one of the main advantages code reusability. Code reusability is nothing but function allows to reuse the code without having to rewrite. Suppose for example, I'm writing one function, something like def is one function I'm writing. So my fun I'm writing. So whatever the code I am writing inside this, there are different operations I can perform inside this function. Suppose same function I want to use multiple times in my application. I don't want to write again and again the same code, same set of statements. Suppose if I am writing 100 statements inside this my fun, so I don't want to repeat again and again. So that is one of the advantage of using function. Simply you can call this function, whatever the function you are using, simply you can use. So that is called code reusability. So only once we are defining, and the same function we are calling multiple times wherever you required in your application. So, code reusability is nothing but so function allowed to use reuse the code, same code multiple times in your application. Only once we are writing the function definitions, same function we are calling multiple times, that is called code reusability. That is one of the advantage. So you can reduce the redundancy and improving the maintainability of a code if you are using a functions concept in our programming languages. So then next, one of the advantage is modularity. So modularity is nothing but whenever we have a complex task, so whenever we need to perform, suppose for example we have a main task, that is a task, that task is divided into different modules. Why? Because this is a complex module. So this module, suppose I want to solve, first I need to divide this particular main problem into different sub modules, something called T1, T2. Then again, if I feel this is not again manageable to perform some operations, then again I am dividing this particular problem into T11 and T12. Similarly, this particular subtask also I am dividing into T21 and T22, something like this. Means main task is divided into different problems, sub problems, and those sub problems, if it is manageable, means you can perform some operations, then you can do that operation. Then finally we need to integrate all these small parts together, and finally we are getting the final solution for the given complex problem. The main intention of this particular functions, we are dividing the main task into different sub problem. So that is called as a modularity. So with the help of that, okay, we can solve easily any complex problem, and finally we can perform debugging easy, and testing also, validations also easily we can perform while dividing that particular main complex problem into sub problems or sub tasks. That is another advantage of function. Then coming to the next one is abstraction. Means functions are providing a way to abstract complex operations. Means when we are performing some operations, those operations are hiding. Okay, those operations are hiding means here only we are focusing on high level logic. We are not representing internal operations. Why? Because with the help of this particular function name, whenever I am calling this particular function, whatever the operations are presented inside that, those operations will be executed sequentially one after the other. But here we are not bothering about what type of operations you are performing internally. Only we are bothering about the high level logic. That is called as abstraction. We are hiding the internal details to the user. Then improving, then another advantage of function is improving the readability. Suppose you are implementing one complex application. Suppose for example, I am writing 1,000 lines of code. If you are not using the functions, what will happen? The readability will be difficult to the programmer or end user, whoever it may be. So why? Because there is a complexity while reading the program. So if you are dividing into different modules or a function, easily we can read. Okay, suppose if we are naming with some name, for you are defining some well-defined name, okay, with function something like my fun. So easily you can identify what is the exactly functionality of this function, what are the operations are performing, easily you can identify. Okay, so the main advantage of this particular readability is easily the developer can understand the code more easily. So that is one of the main advantage. Then next, coming to another advantage of function, that is encapsulation, means functions are encapsulated functionality, means it will hide the complete meaning how function works from the outside. Internally we are performing many operations. Suppose for example many different operations, like maybe you are writing some function like related to arithmetic operation. So inside that particular function, for example, if I am performing something like for example add, for example I am performing inside this add, I am performing different operations. So maybe in subtraction we are performing subtraction related, okay, maybe I am performing multiplication related operation. So you can write any logic, maybe any type of operations you can perform inside this function. So this will hide the what exactly you are performing. Okay, simply we are calling with this name, whatever the name we are defining while creating the function, only with the help of this we are calling and we are executing our functionality. So means all the internal details will be hide, okay, from the outside. So this is called encapsulation. So and the parameterization means you can pass different parameters to your function. Okay, there are different types of ways to pass arguments or parameters to your function, and this is one of the advantage. Dynamically you can pass some parameters to your function, means based on your use cases you can pass different ways, keyword arguments, variable length arguments, like this you can pass. That is one of the advantage. So overall we can say that functions are needed to implement any type of application. So majorly the code reusability, okay, main code reusability purpose, and at the same time, suppose for example you want to solve the complex problem, we are dividing that problem into different small problems, that is called a modularity. That is also very important. And these are some of the important advantages of functions. So that's why we are using a functions concept in any programming language. So what exactly? The next concept is what exactly a function. Technically how we are defining a function. Function is nothing but a block of statements which are used to perform some activity. Like activity is nothing but, suppose for example I am defining one function. Suppose AO underscore function is my function I am performing. Inside this function I am performing something like sum of two numbers. Okay, I am passing two parameters a comma b, sum, subtract, something like I am performing, and multiplication, something like I am performing, like this, division, something a by b, something I am performing. So like this I am performing a different operations inside this function. Okay, so with the help of this name I am calling this particular function. Whatever the operations you are performing inside this function, all these functions will be executed sequentially, one after the other. So the main advantage already we discussed, code reusability, and code will be well organized when you are using functions. Why? Because your task is divided into multiple tasks, means a sub task, modular programming you are using. Okay, means you are introducing a functions, nothing but that is called as a modularity. So when you are using a modularity, means then for the user's point of view also, code reusability is another advantage. Easily we can read, we can understand what exactly what it states, that particular functionality. So easily we can understand. So coming to the syntax, how we are defining functions in Python, that is very, very important. So if you observe this here, this is a major statement. def is a keyword we are using while defining the function. Def is a keyword. This is one of the keyword, and then followed by space and your function name, whatever the function name you want to specify. So this function name should be a valid identifier name. Any valid identifier name you can take it as a function name, and then followed by within the parenthesis you can pass arguments or parameters you can pass. Then after that you can use a colon, then followed by so indentation. Anyway, we are following in Python whatever the block of statements you want to represent, we need to follow indentation. That is mandatory. So we are following one tab space indentation. Inside that we are writing what are the statements you want to represent under this particular function you can represent. Okay, you can represent statement to something like this you can represent. So if you observe, there are different elements are presented in this particular syntax. We'll discuss that one by one. So def is a keyword. Okay, we are using for any user defined function you want to define. Okay, in your application, first you need to use def is a keyword we need to use, then followed by function name. So this is a name of the function. You can take any name, but that function name you need to follow whatever the rules you are following while constructing the identifier name. Same names you need to follow here, same naming conventions. Okay. Then after that parameters we are passing to the function. Okay, these are optional. Okay, suppose for example you are working with some of arguments. Suppose you want to pass, for example, def. Suppose add is a function I am taking. Suppose add, inside that I want to pass two parameters. These two parameters based on the use case. Okay, based on the type of function, how many parameters you want to pass, you can pass. So based on this you can perform your logic. Parameters, maybe a parameter sometimes we can pass suppose simple message I want to represent. I don't want to pass any parameters. Without parameters or arguments also you can define the function based on the use case we are using. And then followed by colon. This colon indicates that your function body starts. When you are representing this colon, okay, based on this it identifies your interpreter. So your function code starts, means actual logic of your function starts from there itself. And inside that, one of the optional thing that is we are using the docstring. Docstring purpose, main purpose we are writing when we are working with the real time. Whenever you are implementing any applications using a functions, we are generally basically we are using thousands of functions we are using to develop one particular real time applications. Basically we are using. So as a developer, I know the functionality of each and everything. Okay, for others also, suppose someone is validating your code, they want to understand easily. For that purpose we are using this particular docstring concept introduced in Python. So docstring they are representing with triple double quotes or triple single quotes we are using. Okay, so with the help of these triple double quotes or triple single quotes we can represent docstring. Docstring represents comments about your functionality, means what is the purpose of this particular function, what are the parameters you are passing. Suppose if you are using any new parameters or arguments you are passing, so you want to give some explanation or a description about those parameters or arguments, you can specify in docstring. So that is very, very important and useful for others to easily understand about your function. Then after that function body, so this is a main important part of this function body. Actual logic we are writing. Suppose I want to perform addition of two numbers, something I am performing, sum is equals to a plus b. Like this you can perform any number of statements you can write inside the function body, means this represents the block of code. This represents the block of code. When you are calling this particular function, whatever the code you are writing inside this function body, so these set of lines or statements will be executed one after the other. Okay, so this is function body. So this is mandatory section. And the return statement, suppose for example if you want to return something to your calling function, suppose if I am calling something for example add something. Okay, for example I am calling this particular function final sum result, s is equals to add, and I am passing 10, 20 something. So final result will be returned when you are using a return statement at the end of your function body. So that value, that return sum, for example I am using, that value returned to the calling function. Wherever you are calling, that value will be returned to the again this particular variable. When you are printing this s, you will get the final result of this complete functionality of add you will get. So that is the purpose of return statement. This is not mandatory. Return statement is not mandatory. You can based on your requirement. Suppose your function needs to needs to return some value to the calling function. In those situations, we are using this return statement. Again, return is one of the keyword in Python. So that is about completely about what is function, how we are defining the function, what is the logic of this function. So we'll discuss that part. Then we have one example for function, how we are defining a function. Okay, this is one of the example. So here initially I said whenever we want to define a function, we need to use def. We want to use def is a keyword. Then after that you need to specify your function name. That should be a valid identifier name. So here I am taking a square is the function name. Square is my function name. I am passing one parameter. That parameter is a number. That parameter is a number I am passing, and I am defining some doc string related to this particular function. That is calculate the square of the number. And what are the arguments I am passing? I am mentioning something like whatever the parameters you are passing. If you want to describe about those parameters, you can write some doc string like number. This is an integer or a float type. Okay, sometimes we don't know what is the type of that parameter. Suppose maybe even you are taking a number type. Suppose if the user passing some string type, okay, it won't work. So for that purpose, clearly we are specifying that that particular parameter type also we are mentioning number to be squared. Finally, what it returns this particular function also we are writing that is square of the input number. So this is the doc string. Okay, this particular part, whatever you are writing in between triple quotes or double quotes, this will not be executed whenever you are calling your function. Only the main logic, this will be executed. Only the main logic will be executed. So the main logic here I am writing here result until this your definition. Until this your definition means the result equals to number into I am squaring this number, whatever number I am passing to this square, I am squaring that, and finally I am returning this result. So where this particular result will be returned whenever I am calling this particular function. So here that result value will be returned. That result value will be returned. Similarly, I am calling the second time. I am passing this time floating point number, and then again that result will be passed to here. So whenever you are calling, so initially you are defining the function definition. Okay, this is called a function definition, and this is called as a function call. This is called as a function call. These two statements are function call, and this is called as a definition. So whenever you are calling this function, then only this particular definition will be executed. So similarly for the second statement also, this particular statement means once I wrote this definition, this particular code, how many times you want to use in your application, you can use. There is no restriction. Maybe 1,000 line, after 1,000 lines I want to call this particular function, simply you can call. Immediately it goes to the corresponding definition and your function definition will be executed. Finally, wherever you are calling, finally that return statement returns that value to the corresponding calling function. Okay, like that your function will be executed. Next, coming to argument passing, means what are different ways to pass the argument. This is very important. Why? Because in many of the applications we need to pass sometimes dynamically, we need to pass some parameters. Sometimes maybe a fixed number of parameters we need to pass. So in that situation, we have different types of ways to pass arguments or parameters to the Python function. So Python supports various types of arguments passed at the time of function call. So what are different ways? One is default arguments, that is one of the method, and the second one is keyword arguments, that is also called as a named argument, and the third one is a positional argument, and the fourth one is arbitrary arguments. We'll discuss one by one. So first one is default arguments. Default argument is nothing but suppose, for example, if you are not passing, for example, if I am taking something, my fun is a function I am taking here arg, okay, then I am writing some logic, print the arg. I am not writing anything, simply I am printing that particular argument. So this is my function definition. Whenever I am calling this my fun, okay, if I am passing something like for example 5, this particular function will be executed and 5 will be printed. This is normal way. Suppose in some situations, for example, I don't want to pass this particular value. I need to take some default value, like one of the best example here. For example, when you are working with the banking applications, so for example, you are writing a functionality for calculation of rate of interest. Calculation of rate of interest. For example, you want to rate of interest. For example, you want to calculate. So at that time, rate of interest is fixed for every customer. Rate of interest is fixed. Suppose maybe a 10% or maybe 15% rate of interest is fixed. I don't want to pass, okay, for every customer, what I am doing, just I am passing the name of the customer and bank ID, something I am passing, only these two parameters. Third parameter I don't want to pass. For example, for first 100 members, rate of interest is 10%. So in that situation, what I am taking here, here I am taking the default arguments concept I am taking, okay, means that default value, whenever I am defining, I am taking this default argument. I am taking this default argument. So let us see that example. Yes. So this is a program related to default arguments. Suppose if you observe, I am defining one function, my fun. I am passing two parameters, x, y, but x is here default. X is a default argument or a default parameter. So what is the use of this default? Whenever you are calling the function, if you are not passing that particular parameter, automatically it will take this default value. If you are passing something, whatever the value you are passing while calling that particular function, that will take as usual. So if you observe this, I am calling this particular function, my fun of 10. So what will happen here? I am actually your function definition expecting 2 arguments, but you are passing only 1 argument. So what will happen? So if you are not, even though you are not passing the second parameter, the first parameter as it is, that will be stored in x, means x value is 10, and the second parameter you are not passing, automatically the default value will be considered. So means when you are printing or when you are performing some operations on x and y, so these 2 values will be considered. Similarly, while calculating the rate of interest, okay, similarly, so you are mentioning something, for example, DEF, I am taking a rate of interest, ROI, I am taking a function name, I am passing a user ID, UID, and RI, I am taking that rate of interest is 10, by default I am taking. So when you are writing some logic, okay, internally you are calculating some rate of interest, compound interest, or maybe some interest you are calculating. So I is equals to PTR by 100, something I am taking. Okay, PTR by 100 I am taking. So all the parameters you are passing, principal amount, time, and rate of interest anyway I. So when I am calling this rate of interest function, okay, principal amount I am passing 1000 something, time is passing. I am not passing the rate of interest. So what will happen? If we are not passing that value, automatically it will consider rate of interest as 10, like this. Similarly, if you observe the second example here, okay, I am passing for the first time I am calling with only 1 parameter. So in place of name, alias will be taken and age default value will be considered. For the second calling, so you are passing 2 parameters. What are the 2 parameters you are passing? Here Bob will be taken. Here Bob will be, okay, and here whatever the age you are passing, that will be stored in age variable. So if you are passing both the parameters, those values will be considered. If you are not passing any parameter, if you are creating that particular variable as a default, so that will be considered. Next, second method to pass arguments or parameters to your function, that is keyword arguments. The first one is a default argument. Okay, then the second one is a keyword argument. Arguments passed to the function with their names. Suppose if I am passing something, for example, I am taking some function. Okay, I am taking some function. Fun1 is a function I am taking, and I am taking some function with name, okay, and age, something I am taking, name and age I am taking. Okay. So whenever you are specifying, Okay, whenever you are passing parameters with the names, nothing but you are writing some logic, you are calling your function with a name, means what exactly that variable you are passing, means you are specifying names of those variables and you are assigning some values here. So this is called as a keyword, means you are specifying key and value, key value you are specifying. Whenever you are calling the function like this, okay, whatever the names here you specified, based on that it will take, means here one important point you need to observe in keyword arguments, order is not important. You can specify the order of parameters in any order while calling. Why? Because you are specifying with the names, based on that your interpreter will understand, okay, a name will be stored in name only, okay, and age will be stored in age variable only, it will store. Okay, that is the purpose of keyword arguments. You are mentioning with some names. Here if you observe this particular example, okay, you are creating a student as a function, first name, last name I am taking keyword argument, and first name I am taking a name and I am passing something, last name I am taking some value. So when you are calling like this, first name will be stored as a Sai and the second name will be stored as a Ram. Similarly, when you are calling the second function, second time, last name is Ram and first name, means order is not important. In any order, you can pass the parameters to your function and based on that name, it will identify the corresponding value. So that is a keyword argument. And the third one is positional arguments. Argument must be specified in the correct position. Previously in keyword arguments, order is not important. But this time position, exactly in which position, okay. So the position is very important. So here if you observe this particular example in positional arguments, so you are defining one specific function, def, great, I am passing a name and I am passing, okay, here whenever you want to specify, okay, for example, def fun2 and name age if I am taking a function, and simply I am printing whatever it may be, some logic I am writing inside this, and here what I am doing, I am calling this particular function fun2 and I am passing a name, okay, Sreekanth, I'm passing Sreekanth, I am passing, and age is 33 I am passing. Whatever the order you are passing, means in the same way the values will be stored. Here Sreekanth will be stored in name variable and 33 will be stored in age variable. This is called positional. This is called as a positional argument. Suppose for example, if you want to use both positional as well as keyword arguments within the same function, then in that case what we need to do here, while defining this okay, function, here you need to use one symbol / you need to use. Whenever you want to define both positional as well as keyword arguments within the same function, first you need to specify the positional, then after that keyword argument, then after that keyword. This is the order you need to follow. So for that reason we are using this /. You are defining like this. Whenever you want to use both in one, okay, function, you need to use like this. Name is the argument and the second one is a symbol / we are using, and age. To separate these two, we are using this / symbol we are using. Means if you observe, while calling this particular function, okay, I am passing greet, alias, age. Alias will be stored in name variable, and age is a keyword argument. Alias is a positional argument, age is a keyword argument. Alias will be stored in the corresponding name variable. Age, anyway you have a age variable, under that age will be stored something like this. Okay, if you are not specifying, what will happen? Okay, suppose clearly you are stating that this is positional, as it is that this particular value will be stored in name and age will be stored. Suppose if you are taking age first, then after that for example, if you are passing age comma, for example, alias, for example, if you are taking, you will get error. Means Positional arguments followed by your keyword argument. That is the order. Whenever you want to use both keyword arguments and positional arguments within the same function, first you need to pass, even while defining, first you need to pass the positional arguments like this, and then followed by forward slash as a symbol, then comma, followed by whatever the keyword arguments you want to use. You need to pass. So like this you need to use. So this is a positional arguments, as well as we are using keyword argument. So this is example for positional, only positional. There is no keyword argument, and this is example for both positional as well as keyword arguments. And this is another example. If you observe this particular definition, name, age I am taking. Okay, I am passing here name. Okay, this is the first case I am taking, Suraj and 27. This is a name, age as per the order. So this is positional. And here we changed this order. 27 and 27 is age. But as per this definition, what is expecting first? Name. So means whatever you are passing, name will be stored 27, and age contains some name Suraj. It will store. Is that meaningful? No. So whenever you want to pass positional arguments, as the you need to follow some order. Whatever the order you are defining in your function definition, in the same order you need to pass parameters while calling the function also. That is important point you need to remember while passing the arguments or parameters to your function. So that is about the positional arguments. Then coming to arbitrary arguments. Arbitrary arguments nothing but in some situations we don't know how many parameters we want to pass. For example, fun is a function. I don't know exactly in advance. Okay, I don't know how many parameters I need to pass. In that situation, so this will be helpful. Arbitrary arguments. Okay, so how you are using arbitrary arguments? Again, you can use arbitrary arguments with the help of asterisk symbol we are representing. Okay, arbitrary keyword arguments. Okay, you can take arbitrary keyword arguments, arbitrary positional. Means variable length. Simply arbitrary nothing but variable length arguments. Means we don't know how many parameters or arguments we want to pass. In that situation, this will be useful. So we can represent that arbitrary number with a star. So before that variable name, we need to pass star. So variable length non-keyword arguments, nothing but not a keyword. Simply we can say that variable length positional. Variable length positional arguments. Variable length positional argument. So variable length positional arguments nothing but, suppose for example this is my use case to find out sum of multiple numbers. Means I'm not specifying 2 numbers, 3 numbers. Maybe if I am passing 3 while calling first call, suppose find sum is my function. Okay, whenever I am calling this function, first time I am using 10, 20. First time I am using 10 and 20. Then next time I am calling with 10, 20, 30. Next time I am calling with 10, 20, 30, 40. Next time. So I don't know how many parameters I am passing while calling. In that situation, this arbitrary number of arguments will be helpful. So variable length non-keyword arguments nothing but positional argument. Suppose if you observe this, okay, find some 1, 2, 3 I am passing. Okay, whenever you are defining function like this you need to use. Okay, whenever you want to use arbitrary, so before the variable name you need to specify asterisk symbol, asterisk numbers, nothing but. So suppose if you are passing 1, 2, 3, 3 parameters will be stored in this number. Okay, sometimes we are using args is a parameter also. Okay, in some textbooks, okay, they are representing args. You can give any name. Okay, so that is not an issue, but before that variable name you need to specify, okay, asterisk symbol. So if you are specifying like this, nothing but this represents the arbitrary number of arguments. That arbitrary number of arguments, that may be a positional arbitrary or else may be a keyword argument. So this is the example for arbitrary non-keyword arguments nothing but, that is a positional. So simply 1, 2, 3 nothing but. So this will be stored as a tuple type, guys. This will be stored as a tuple type. So tuple type nothing but tuple is nothing basically represented within the parentheses. The values when you are printing here, suppose print for example I am using numbers, that is my variable I am taking. When you are printing numbers, it will print something like 1, 2, 3. Finally, you will get output something like this. You will get something like this. When you are using arbitrary length, okay, non-keyword arguments, nothing but you will get output like this. Okay, whenever you want to perform summation, simply you need to iterate with the loops. For num in numbers, this is a tuple, and one by one value will be iterated, and that value will be added like this. Result equals to result plus num, and finally that value will be returned whenever you are. I am calling here only two arguments I am passing, and this number contains two values something like 4, 9. You want to add, so iterate with this tuple, okay, one by one value and add, result equals to result plus num you will get. Okay, this is a variable length non-keyword arguments example. Then the second one is related to variable length keyword arguments. So variable length keyword arguments nothing but, okay, I am passing with the names. I am passing with the names. I don't know, for example, in advance, I don't know how many keyword arguments I want to pass. In that situations, we are using this use case. Like whenever you want to use, okay, variable length okay, keyword arguments, in that situation you need to use double star. Previously we used for a single star we are using, while representing a variable length non-keyword arguments we are using single star. For a variable length okay, keyword arguments we are using double star before the variable name. Before the variable name you need to use. So same way here we are using, and we am I'm defining some function. Okay, I don't know the number of keyword arguments I am passing to the function call, so that's why I am taking here variable length keyword arguments, nothing but double star followed by variable name. And when I am calling this, so you can pass any number of keyword arguments. Okay, you can pass, maybe suppose one argument you can pass this keyword arguments. Finally, this keyword argument is a dictionary type. So dictionary type nothing but the values will be stored something like key value type, the key value type. So you can use here you have one method called items, okay, in your dictionary. So with the help of that you can get the key as well as value separately. You can get key and value. So key is nothing but here first, okay, is a key, and value means a geeks. Similarly here mid is a key and value is for, and similarly here like this key value pair. Okay, if suppose you don't know how many parameters you want to pass, suppose for example I am passing my fun, okay, for example I am taking first name, first is Sreekanth, okay, I am taking Sreekanth, and the last name K, for example I am taking, so I am passing 2. I am calling the second time, this is first time I am calling with a 3 keyword argument, and the second time I am calling a 2 keyword arguments. And now, okay, here the keyword contains a dictionary like something like if you observe first when you are printing key args, you will get something like this. You will get first one is first, you will get Sreekanth, something like this. So you will get Sreekanth, and the last one you will get something like a last name K, you will get something, you will get finally. So if you want to extract this one by one, you can use here items is a method from this dictionary. You have items method, so you can access those two values, key and values you will get. So that is about variable length keyword argument. So guys, so far we discussed about different ways to pass arguments or parameters to your function. Okay, one is a positional argument, okay, one is default argument, then other one is a variable length argument, okay, that is a arbitrary. Variable length arbitrary means a non-keyword arguments, variable length keyword arguments, different ways. Based on your use case, you can choose. Whenever you want to use both variable length means a keyword arguments as well as a positional arguments, in that situation, first you need to pass positional argument, then after that keyword arguments. Then after that, you can pass keyword argument. That is the order. If you are passing first keyword argument, then variable length positional argument, suppose you will get error. You will get error. Then coming to the types of functions. So this is another important concept in functions. What are different types of functions are available? Here in Python functions, okay, here we have user defined functions and built-in functions are there, lambda functions are there, recursive functions are there, something like generator functions are there. We have a different functions. We'll discuss one by one. So what exactly built-in function? Built-in functions are nothing but predefined. Means whoever is developed this programming language, maybe a Python, maybe a Java, maybe a C, whatever it may be programming language. So built-in or a predefined function, or sometimes we are calling as a library function. Built-in or a predefined, built-in or predefined functions we are calling. Means already, okay, whoever developed this programming language, so they are defining the logic. We are not defining the logic, only just we are using those functions we are calling, and the corresponding functionality will be executed. Means we don't know what exactly the internal operations inside the inside those functions. Suppose if I am using len is a one function we are using in Python. Len is a function used to find out the length of the list, length of tuple, length of dictionary, length of set, or length of the string, something you want. Okay, whenever simply if I am passing, for example, str1 is equals to something I am taking, okay, something I am taking. So when you are passing len of str1, it will return the length of that particular string, simply it will return. We don't know what is the logic internally inside this len. Who developed this particular programming language? They are writing an internal logic. Okay, that is called as a data abstraction. So simply we are using this function whenever we require. Simply we are calling that particular function. That's it. Those are called as a built-in. Like this, you have thousands of functions are there in different modules in a different packages in Python. Like math related, okay, mathematical module related functions are there, tan, sec, cosec, cot, something. Okay, log values, you have a logarithmic function, absolute value if you want to find out ABS function. All these are mathematical related function. And similarly, suppose you want to find out a minimum, maximum, you have some built-in functions are available. So we are using those built-in functions. Those are called as a predefined function. Maybe input. Suppose whenever you want to take a input from the user, we are using input is a function. Okay. Suppose for example, input value is an integer. So by default, it will be taken as a string type. I want to convert into integer type. Then again, I am using one more built-in function, int I am using. So all these are predefined. So that's why these are called as a built-in functions or library functions generally we are calling. And this is one of the example for some of the built-in functions, okay, which we are using in our Python. So something like I'm declaring some variables num -10 and I'm printing absolute value. Means maybe you are entering a positive value, negative value, finally it will display the positive value. Even though you are entering minus, okay, absolute returns a positive value, something like. So bool list, suppose I want to find out, okay, all the list of elements are true or not. If it returns, okay, all means all the elements are of same type, true means, okay, then it will return true. Okay, similarly num10, for example, I want to convert into bin is a one built-in function, it will convert that into binary value. This is 10, this particular input is a decimal value, I want to convert this decimal value into, okay, binary number, then we are using bin is a function, bin is a built-in function we are using. I want to find out the list of these values, you can use len is a, okay, built-in function we are using. So like this you are using, okay, maybe enumerate, we have a multiple built-in or a predefined functions are there. In our day-to-day programming we are using a different functions we are using. So that is about built-in. Then coming to user defined function, whatever the functions previously we created like my fun, okay, something we created, na? As a developer, so okay, you can define your own function. Those are comes under user defined. As a developer, suppose I am the developer, I want to, okay, define some functionality related to arithmetic operations, something like def AO is a, okay, function I am defining. I am passing some arguments based on my use case. So inside this I am performing some logic, subtraction logic, subtraction, multiplication, okay, division, something I am performing, different operations I am performing. Okay, here this is my user defined name. Okay, whenever I am writing this logic, I am naming this. Okay, all the operations are placed under this particular name. So if you want to execute all these operations, you need to call this function. Okay, simply if I am calling AO of 10, 20, something I am calling. So immediately this particular definition will be executed. So this is the user defined one. Okay, as a user, as a developer, you can define your own function. So that is comes under user defined function. Okay, so you can create any number of user defined function. There is no restriction on the number of user defined function, but properly you need to define whatever the syntax we discussed previously to define the function. Same okay, syntax you need to follow. Def is a keyword, then followed by function name, and then followed by within parenthesis arguments or parameters, then followed by colon, then followed by, okay, if you want to define the doc string, you can define the doc string also. Then after that actual okay, logic you can define. So properly you need to define, that's it. Okay, if you observe this example, okay, simple example, greet is my function name. I am passing one parameter and finally I am returning that value, hello, okay, alias, something I am displaying. So this is a user defined function. Then comes to different types of functions other than built-in and user defined function. Something this is different. Anonymous functions are lambda functions. Lambda functions are anonymous functions in Python. Okay, so basically anonymous function or lambda functions are nothing but unnamed functions. Basically there is no name for basically when you are using a user defined functions or a built-in function, some name will be there, something like a def fun is a function name you are using, is that right? So but for lambda functions or anonymous function, there is no name. And in what type of use cases we are using these anonymous or lambda functions? Nothing but whenever you want to represent some logic in a single line statement, if the logic is small, then in those use cases you can use these lambda functions or anonymous functions. Shorter code whenever you want to represent, okay, you can use this, okay, anonymous function. How we are using syntax for lambda function? Okay, first keyword lambda we are using. Lambda is a keyword, then followed by arguments. You can pass any number of arguments, then followed by colon, then followed by expression. Okay, this expression is nothing but whatever the logic you want to write, okay, you can write here. In place of expression, you are writing your logic, what you need. Suppose for example, I want to perform addition of two numbers. You can write your logic here, a plus b, I am passing. Okay, how many arguments you want to pass? You can pass those many arguments here in argument section. Okay, and here suppose if you observe the simple example for lambda function, okay, here I am taking lambda, okay, is a keyword, and I am passing a single argument colon, and this is my expression, means whatever the value I am passing, for that particular value 10 will be added. Okay, and then finally that value will be stored in add underscore 10, the result. So this is your lambda. This is your lambda. We are not giving directly the name of the lambda function or anonymous function. So simply whatever the variable you are assigning this particular result, that will be treated as a name of your lambda. Okay, but this is a nameless function. Okay, lambda function is nothing but a, okay, nameless function. There is no name. Add underscore 10. Okay, suppose 10, simply you are passing 5. So it will take argument section, one argument 5, and whatever the logic you are writing, that logic will be executed. So even you can pass multiple arguments also. If you observe this particular example here, two arguments I am passing. I am assigning to multiply, and for multiply I am passing. You can take mul as a variable. For mul you can pass 10, 20, you can pass. So in place of x comma y, x 10, y 20 will be taken, and finally if you want to perform multiplication, x into y logic you are writing, means 10 into 20 will be performed, and finally that result will be stored in multiply. That result will be stored. Whenever you want to use a simple logic, the code you want to represent in a single line, precisely you want to represent your logic, in that case, okay, these lambda functions are useful. Okay, and the readability wise, okay, more readable compared to your normal ordinary functions, readability wise also. And you can use this lambda functions with some built-in functions also. Lambda functions with built-in, nothing but there are some functions, something like map, filter, reduce we have. Okay, these are very, very important functions. Map, filter, reduce. There are three different types of functions are there. Map function purpose, the functionality of map, whenever you want to perform some task on each and every element of your iterables, then in that case we are using a map. Applies a function to all items in your input, maybe a list, maybe a tuple, maybe a string, okay, whatever it may be iterable you are taking. On that iterable, suppose you want to perform, okay, some functionality, in that case we are using a map is a function. Suppose if you observe this list, numbers is a list, okay, I am taking numbers is a list 1, 2, 3, 4. Simply I want to square this every element, I want to square each and every element in this list n. So for that, how I am using this particular map function? Simply, okay, map, okay, I am writing inside this map, I am passing, okay, one is function we need to pass, one parameter is, two parameters actually we are passing, one is any function, okay, you can pass any function, maybe a built-in function you can pass, or maybe anonymous function or a lambda function you can pass, and the second argument is what is the iterable you are using, what is the iterable. So on what you need to perform this particular functionality you need to mention. So map, okay, here I am passing lambda is a function I am taking. In this particular use case I am taking lambda function. You can define your own user defined function name also, you can specify here. Instead of lambda function you can take. So lambda, then one argument I am passing, means every argument I need to consider, okay, from this iterable list n, okay, then I need to perform something square of each and every element in the list. So one will be considered first, 1 square will be performed, then second element will be considered, 2 square will be performed, next 3 square, then 4 square, like this one after the other will be performed. And if you are not taking this list is a built-in function, okay, it will return as a iterator object. Iterator object will be returned, it won't return this output. So whenever you want to get this output, you need to convert into list. So that's why we are using here list of this entire map, and that result will be stored in squared. When you are printing square, you will get like this, you will get like this squared, okay. And that is about map. Like this you want to perform okay, square or multiply each and every number, for example with 2, for example 1 into 2, 2 into 2, 3 into 2, something constant value, then in that case also map will be applied. Means whatever the functionality or the logic you want to apply to all the elements or items in a given input list, in those situations, okay, this map function will be useful. Then coming to the second one, okay, filter. Filter is another useful functions frequently we are using in our application. Whenever you are using, okay, for example, I have some list of elements, maybe 100 elements or 20 elements, whatever it may be, number of elements presented in the iterables, maybe a list, maybe a tuple, or maybe a string you can take, and suppose you want to filter, means suppose I want to filter even numbers, okay, I want to filter even numbers, then in that case this particular function will be, okay, useful. Means based on some condition I want to filter the list of elements, okay, or a list of items which are presented in the corresponding iterable. In those use cases this filter will be useful. So construct an iterator from the elements of an iterable for which a function returns true. Means whenever you are performing, if you observe the logic here, filter, okay, previously we used map, now we are using a filter. Now lambda is a function. You, in place of this anonymous function, you can use your normal user defined function also. So argument is every time I need to take one element from the list. So x, only one parameter, and x mod 2, what is the condition here? Okay, even numbers I need to filter. For that I am writing x mod 2 equals to 0. If this condition is true, it returns true. It returns true, nothing but the corresponding value will be, okay, returned. The corresponding value, suppose 1 mod 2 equals to 0. No, next value is 2. 2 mod 2 0. So that value will be returned. Okay, that value will be returned. Okay, means here numbers, this particular numbers list contain 1 to 10, and each and every value will be checked. If the condition is true, only those values will be returned to the even underscore numbers. Even while using a filter or a map, okay, you need to use okay, again list. Why? Because it will return iterator object if you are not using this particular list function. Okay, so that is about filter function. Then coming to, okay, the next one is similarly, okay, whenever you want to sort the elements, okay, then you can use okay, this particular anonymous functions. Okay, sorted is a built-in function. Inside this, basically you want to apply the sorting will be performed on this key functionality. Key is okay, the first element. Based on this first second elements will be sorted. Second element will be sorted. Okay, so you can use lambda function. Okay, whenever you are performing some logic in a single line, okay, then in that use cases you can use. And the last one is okay, you can use filter and reduce. Reduce also you can use. Reduce, suppose, but for example, if you want to use a reduce function, okay, reduce function, we need to import one specific module. Okay, from func tools you can use a reduce. From func tool import reduce. You need to use this, otherwise you will get error if you are using directly reduce. So how you can use reduce? Suppose I have a list of elements, something like 1 2 3 4, something like, I want to use reduce. Simply here reduce, and inside this I am writing a logic, something like lambda. You can use lambda or anonymous, and here I am using x comma y, and I am performing x plus y. Okay, x plus y, and then comma this particular list element. So it will take these two elements first time, and corresponding action will be, logic will be performed. X is 1 first time, y is 2, x comma y, x plus y, nothing but 3. Then next time again, okay, then next time this particular result is x, whatever the result here you are getting, that is x, okay, and this one, this is y. Then again 3 plus 3, x is 3 and y is 3, and x plus y is nothing but, okay, x plus y is nothing but 6. Then again, okay, whatever the result you got, this is x, nothing but 6, and this value, x is 6, y is 4, then finally x plus y is nothing but 10 you will get, like this. So like this your reduce function will be work. Okay, whenever you want to use a reduce, so you need to import this module from func tool, func tool, import reduce. reduce. But when to use this particular lambda function means, so short and simple functions for simple operations that are only needed once, okay, in your functionality, then in that use case you can use, okay, and no need to define any functionality, avoiding function definition. That is one of the advantage. In those situations you can use lambda functions, okay. And limitation, there are certain limitations to use lambda functions. Again, one is single expression. They can only contain single expression and cannot include statements and annotation. Means simple application. Suppose if you observed in the previous example, so we used this particular lambda function in a simpler manner. If you have some complex logic, in those cases you cannot use this lambda function. You cannot use, okay. And over usage of lambda functions, multiple lambda functions you are using, it's very it's very difficult to understand that also, okay. That is another thing. So if it is a simple code, okay, then in that use case you can use lambda function. And okay, this is another type of functions basically we are using, okay, in every programming language. Recursive function. The recursive function is nothing but the function calls itself. Means a function calls itself nothing but, suppose for example I am taking a factorial. I want to find out factorial. I am defining one specific function def, okay, fact. I am passing some arguments. Okay. Inside this, okay, I want to perform some logic related to factorial of given number. Okay, I am not creating this particular logic iteratively, means I am not using any loop control statements or anything, any for loop or while loop I am not using. I don't want to use. I want to, okay, call the same function whatever I am calling. With the help of that only I need to iterate the next one. So that we are using in recursive function. Okay, recursive functions are the functions that calls themselves in order to solve a problem by breaking down into smaller subproblems. Okay, basically, okay, two elements we are using in a recursive function, any recursive function. One is a base case, the second one is a recursive case. Base case is nothing but at one point of time we need to stop that particular process. So for that we require this base case, the condition under which the recursion stops. Where we need to stop, that you need to mention. If it is factorial of given number, I am taking a factorial of 5. So you are finding until 1. Once it is 0, we need to stop. Or else once it is equals to 1, we need to stop. Somewhere we need to stop. So that condition is called as a base condition. And recursive case is nothing but the part of the function where the function call itself, that repeatedly you want to call the same function, that is comes under recursive case. If you observe this particular example, nothing but factorial of given number. The factorial of given number I am writing logic like this. Base case I am defining first. For every recursive application you need to define like this. First you need to define the base case. This is a base case you need to define, and this is called the recursive case. Recursive case. Base case for the factorial of given number is if n is equals to 1, simply return 1. Otherwise, then go to the else, and recursively we are calling the same function. Whatever the function we defined here, same function we are calling here. Okay, this is called function calls itself. When you are calling same function within your logic, then it comes under recursive function. So like this, I am calling this recursive function. Okay. You can define the same program with the help of iterative approach also. Iterative approach is nothing but we need to use loop control statements. Either you can use while or for, you can use with the help of while and for also you can solve this. Okay, but the performance wise this is the best one. Okay, recursive applications are the best one. Why? Because for some use cases okay, we cannot implement using iterative approach. For those use cases like something like for example factorial, this is fine. We can implement using a iterative approach and using a recursive approach also. Towers of Hanoi problem is there. One of the application, Towers of Hanoi. Towers of Hanoi application, okay, it's very difficult to solve using iterative approach. In that situation, we are using a recursive approach. We are defining the base case and we are defining the general case, that is a recursive case. So simply we are solving this Towers of Hanoi. Not only this, you can create multiple, means Fibonacci series. For the Fibonacci series, if n is equals to 0, okay, n is equals to 0, or n is equal, if n is equals to 0, return simply 0. Else, okay, if n is equals to 1, return 1. Else, otherwise, FIB of n minus 1 plus FIB of n minus 2. Like this, you can define. You can define. So first you need to define the base case, then after that you need to define the recursive case for any recursive application. So this is another program, Fibonacci series. Okay, if recursive case, first we are defining base case, then recursive case for a Fibonacci series. Okay, FIB, I mean whatever the function name you are taking, that function name I am taking here. Fibonacci of n minus 1, okay, plus Fibonacci of n minus 2. I think everyone knows Fibonacci series. Something initially you have a 0, 1, and the next value in the sequence addition of these two. That is the main logic. FIB of n minus 1 plus FIB of n minus 2. So the addition of previous two elements nothing but 1, then again previous 2 is nothing but these two elements, so 2, and again previous 2 is nothing but 3, and again these two elements 5, something like this you will get. This is Fibonacci series. And already we discussed this map function clearly. Filter, reduce function also we discussed already. Okay, so we need to import this module. Func tool is a module we need to import whenever you want to use reduce function. Okay, so some of the elements we are using reduce function, something like this. Okay, we are defining the definition, return xy. Okay, this is built in. In place of this, you can take okay, lambda functions also. Lambda functions also you can take. Instead of this logic, reduce lambda x comma y colon x plus y comma that numbers you can take. So maybe lambda function used, but finally we need to pass one function. If you are passing user defined function, that function name you need to pass. Here the function name is add, here add you need to pass, and what is the iterable you are using, that iterable name you need to pass. If it is numbers, if it is suppose n, you can pass n here, and simply it will perform. Okay, it will, if you observe the reduce function, you are not using any typecasting, is it right? Okay, means directly it will return the value. After reduction of that particular logic, you will get a one value. But whereas a map function or else a filter function it returns the iterable object. So for that you need to use again list of that particular map you need to return like this. So this is very, very important concept in any programming languages. Functions are very useful. Okay, easily you can debug your code. That is one of the biggest advantage, and reusability is another advantage. Same functions you can use multiple times in your application simply with the help of one line. No need to write. Suppose if you are writing a code with one function with 1,000 lines of code. So you are giving some name for this particular 1,000 lines. You are defining with some name, something like fun or something, some function with 1,000 lines you are defining. I want to use the same logic, then simply you can call this fun. That's it. No need to write 1,000 lines of code. Okay. So unnecessarily Okay, you are writing, suppose if you are not using a functions, unnecessarily you need to write 1,000 lines of code. Your time will be saved, your space will be saved. So these are the advantages of using functions. Okay, you can achieve modularity also, modular programming. You have some complex task is there, you can divide that particular task into sub tasks, and you can easily solve that particular problem, and finally you can integrate all the subtasks solutions into a main problem solution. Easily you can solve. That is the advantage of functions. So that's it guys about the functions.
Like, share and subscribe. Hit the bell icon for more updates.